Welcome to this short presentation introducing the physical concept of an inclined plane. An inclined plane may look like this one, and it will be defined by the inclination angle, which is shown as alpha here. This plane is only interesting for us because there is something standing on top of this plane, for example a cart or a crate or whatever. If we have an object on top of this plane, this means that we also have the gravitational force acting directly downwards in the vertical direction, and this force, named here F with index g. It's not F times g, this is just a name of the force, okay? Fg is the full symbol of gravitational force. Gravitational force equals to mg. This is on the power of the second law of motion, where m is the mass of our cart and g is the gravitational acceleration, equal to 9.81 meters per second square, but in most calculations we will round it up to 10 meters per second square. So basically this gravitational force is simply mass multiplied by 10. Okay. Next thing is that we can decompose this gravitational force into two smaller forces, which are more practical for us to use. One of these forces is parallel to the surface of the inclined plane, and this force is responsible for sliding objects down the slope. So this force is also known as the sliding force. The other force is perpendicular or normal to the surface of the inclined plane, and it is slightly less interesting but also important. What's nice is that we can reasonably easily find the values of both forces by looking at these two triangles. We have a small triangle here and another small triangle here. It's easy to notice that both triangles are right triangles, and these triangles are also, in maths we call it similar to the big triangle of the inclined plane. Similarity in maths means that basically the inclination angle alpha appears here and here in our smaller triangles. Now, using a little bit of SOHCAHTOA type of trigonometry, we can find that the sliding force, this shorter arrow responsible for moving things down the slope, this is an opposite edge in the triangle for which the hypotenuse is equal to mg. If it is the opposite edge, this means that the sliding force will be equal to mg, the value of hypotenuse, multiplied by sine alpha, sine of our inclination angle. Very similarly, the longer arrow, which is the normal force perpendicular to the surface of the inclined plane, can be found from this triangle here as the adjacent edge. Therefore, the formula here is mg times cosine alpha. Okay, so far so good. So let's make some notes. So the first of our forces will be called a sliding force. We'll call it Fs. Again, S is just the index, it's not a separate variable, it's the index, so a part of the name of the sliding force. Basically, sliding force is Fs, and it is mg sine alpha. The longer force, the normal force, will be called Fn, and it is mg cosine alpha. The sliding force is important for us because it directly makes the things moving, of course, down the slope. The normal force is the force with which the object presses onto the surface of the inclined plane, so seemingly it doesn't create any movement because this normal force will be balanced by another force which the inclined plane will act onto the cart according to the third law of motion, that law about action and reaction. And this follows our everyday experience. A cart in a typical situation like this, unless the inclined plane is very muddy, will not sink, will just stand on the top of this plane. But the normal force is responsible for another phenomenon which is very important for us, and this phenomenon is known as the friction. Friction is a kind of a pseudo force, so kind of a force. Okay, it's shown here with this green arrow. The friction force will always act against the current movement of any motion. So it will try to prevent the sliding movement of the object. So basically, friction looks like it's acting up the slope. Alright, the point is that the friction force, according to the laws of physics, depends on the normal force. So the harder you press the object towards its basis, this plane on which it's, or ground on which it's standing, the stronger friction. And in this case, friction will be equal to lowercase f. Lowercase f is so-called coefficient of friction, which means how big portion of the normal force is directly converted into friction, and this coefficient of friction has to be multiplied by the normal force. So the final formula for the friction force is Fmg cosine alpha, similar to the normal force. And with these three formulas, we are ready to do any kind of a mathematical question, exercise about objects moving along the inclined plane. So let's give it a try. Okay, I also have the friction formula added to the diagram, but here is our first exercise. A crate is sliding down a ramp. Find the time it takes to hit the ground starting from a standstill if we know that inclination angle of this plane is 30 degrees. The height of this inclined plane, which is shown here as this edge, h, is 4.13 meters, and we also have lowercase f. This is coefficient of friction 0.1. We also have a diagram with all the forces already shown here. So we have the sliding force mg sine alpha, normal force mg cosine alpha, and they are of course both derivatives of the not derivatives, that are associated with the gravitational force mg. So the first step in any exercise question like this is actually a no-brainer. Okay, we just start with saying, okay, we will have a sliding force Fs equals mg sine alpha. A normal force equal to Fn mg cosine alpha. And the friction, it looks like my Alexa tried to tell me something. Sorry for distraction. Friction is Fmg cosine alpha. And with these three forces, I will now switch to manual pen, and let's continue. First of all, in any type of physical exercise which includes forces, we should think about something that is called the net force. Net force is the final force which is a combination of all the other acting forces here. So our net force, I will call it simply F, equals, first of all, the sliding force which is moving our crate down, so this is Fs, and we have a friction force which tries to prevent this motion, and the formula for this net force actually was here under the diagram. So this is Fs minus Ff. Please note that normal force is not directly included in this formula. We have the sliding force and the friction force, the two forces that are directly observable in our situation. So let's solve it further. The sliding force is here, and it is mg sine alpha. The friction force is here, so it's minus fmg cosine alpha. And this formula is quite a universal formula which will which will appear in most questions whether it involve inclined plane. Sometimes instead of negation, instead of minus, you will see here plus. Okay, one of the other exercises in this series shows a situation in which we should actually add friction to the sliding force, but this is not the case here. Here friction is definitely preventing the sliding force, so this is our formula. What I can further do with this, I have this component mg both here and here, so I can rewrite this formula extracting mg in front of a bracket, and in this case in the bracket I have sine alpha minus, don't forget about f, minus f cosine alpha. And this is my formula for the net force. Having the net force and following second law of motion, which includes involves forces, accelerations, and masses, okay, we can find we don't need mass, but we need acceleration. Okay, so acceleration will be our next big thing to acceleration, okay, to calculate. According to the famous Newton's formula, acceleration is equal to force F divided by the mass m. So F, the force, is shown here. Please note that the first symbol in the formula for the mass is for the force is m, is the mass. So if we take this force and divide it by mass, the mass will reduce itself, and our acceleration will be just the remaining part of this formula. So it is g sine alpha minus f cosine alpha. And you know what? Until now, this is mostly a standard part of most of the inclined plane exercises. The only tricky thing may be sometimes the symbol plus here and here. Now we'll start to do something specific about this particular exercise, about this particular question. The question here is about the time. Okay, find the time. We have a movement of an object. We know that it is sliding down a ramp. The time it takes to hit the ground, we know this height, 4.13 meters, because we don't know anything else about its position within the ramp. We have to assume, because otherwise this exercise couldn't be solved, we have to assume that our crate initially was somewhere here, okay, on top of this inclined plane, so at the height h above the ground. So basically we have something moving from here downwards, this direction, with a known acceleration. This is an accelerated motion. You know all the formulas for accelerated motion, and this is time to use these formulas. So if we know acceleration and want to find the time, it's not exactly straightforward, but not bad. Basically, time, I will start from saying what happened. Okay, sorry, I accidentally changed the scale of the slide. Time can be found from, for example, from a formula which provides the distance traveled by an object traveling with accelerated motion. X equals at squared over 2. So from this formula we should be able to find time. We already know acceleration, so it's not a big problem. One problem is that we need to know the distance, x, the distance traveled by the object. So please note that if you take it the simplest way, okay, the naive approach, and you say, all right, I know something, I have something in meters, so the distance is 4.13 meters, nothing could be further from the truth, okay? This crate is not falling down, it's sliding down this direction, so our x is here. That's the x. So I will redraw this thing maybe here. So we have a nice little triangle with the angle alpha here, known value of h equals 4.13 here, and we need the hypotenuse, okay, because the crate is sliding down along the hypotenuse of this triangle. What I know, and I will put it here as the distance, okay? Calculation for the distance can be found from, again, the simplest possible trigonometry, just SOHCAHTOA, okay? So sine alpha equals the opposite, so it's h divided by x. And from this formula, x is h divided, so the height of the inclined plane divided by sine alpha. All right, so we know x, we know a, we just need to find t. So from this formula, we can find that t squared for now equals, I have to multiply both sides by 2, so I will get 2x, sorry, it's 2x, and divided by a, so it's 2x divided by a, so t equals square root of 2x over a. And this is nearly everything that we needed to do in this exercise. I will draw a vertical line and put here calculations. Okay, so let's get it done. First thing that I would like to calculate is the acceleration. Okay, acceleration A is g sine alpha minus f cosine alpha. I know f. Usually in this type of questions we will assume that g, the gravitational acceleration, g is 10 meters per second square. The real value on the Earth is 9.81, but it is usually round up to 10. This is not 9, sorry, it's the letter G. Sorry, this looks better now. About the alpha, unlike the mathematical calculations, we will use estimated values. And these estimations, you will usually get estimated values of trigonometrical functions together with the question. It is not here because this is a lecture kind of a question, but in the in-class test you will get it. Sine alpha equals 0.5. This is not an estimation, this is the exact value, but cosine alpha can be estimated at 0.87. With these calculations, I can now say A equals G, that's 10, times sine alpha, that's 0.5, minus f is 0.1 times cosine alpha, that's 0.87. So this is again equal to 10 times 0.5 minus 0.1 times 0.87 is 0.087. So this is 10 times 0.5 minus 0.087 is 0.413 multiplied by 10 is 4.13 meter per second squared. This is the acceleration with which our crate is sliding down the slope. Next thing is the distance. Okay, distance is actually this formula for x, not for sine alpha. X equals h over sine alpha. H is 4.13 meters, 4.13 divided by sine alpha. Sine alpha is 0.5. Dividing by 0.5 is the same thing as multiplying by 2, so the distance traveled by our crate is 8.26 meters. And from this we can now attack the final formula for time. Time will be the square root of 2 times the distance traveled, so this is 8.26 over acceleration, which is 4.13. Doing all these calculations, you can get a square root of 4, which is 2, and this is 2 seconds. This is the answer for this question. The time needed to hit the ground is exactly 2 seconds. Thank you very much, and I invite you to the second question, the second part of this presentation, which will present pretty much similar case, similar exercise. Thank you.